We've been practicing writing names for compounds, learning how to name things. We also need to be able to write formulas from the names. And again, we have to consider what types of compounds are we dealing with so that we know how to apply the rules correctly. So what your book calls a type 3 binary compound. These are the ones with the two nonmetals, and they have subscripts. Back up. These have prefixes, numerical prefixes in their names. Let's just do an example here. There's not one in there, but I can make there be one. So an example would be dinitrogen. That's just really messy. Sorry. Dinitrogen monoxide. So from the name, which we can barely read, we need to be able to recognize what kind of a compound this is. If you're seeing prefixes like this, mono and di, that's a good clue that it's one of those binary compounds of two nonmetals. The other thing is to look at these elements, nitrogen and oxygen. There's two elements there, and they're both nonmetals. So these are the ones that students generally have the least trouble with. Nitrogen has the symbol N, and the prefix di means 2. So the 2 comes after the element symbol. And oxygen is a capital O. Make sure it's as big as your capital N. Mono means 1, and we're not going to write the 1. And so that's the formula for dinitrogen monoxide. We have to use those prefixes because we can't do anything with charges and figuring out how many of each there are.
So it doesn't matter because nitrogen is a 3 minus, that doesn't matter.
No, we can't treat it that way because nitrogen would make a 3 minus ion, oxygen would make a 2 minus ion, and there's no way we can get negatives to add up to be 0. You got to have a positive. Your question?
Why do you say dinitrogen when it's in 2? Isn't it always in 2 anyway when it's just...
That's a good question. Isn't nitrogen always N2 because it's one of those diatomic elements, right? The diatomic element business, the horses need oats for clear brown eyes, that's when the element is all by itself. Okay, so here, if we go back to that little junior high girl explanation, I'm trying to get back to my slide. So here we have N2O. Oxygen is also one of those diatomic elements. Why isn't oxygen O2? Well, when oxygen's alone, it's going to take a friend. But here it's part of a group. It's not with another oxygen, but it's got these 2 nitrogens to keep it company. The nitrogens, sometimes there's also a compound that's just NO. There's one that's NO2. So in a compound, if the element is with another element, that whole diatomic element business goes out the window. That is only when the element is by itself. And I'm glad you brought that up because that's a common issue. And I understand why it's an issue because we drilled that into you and now you're saying, but it doesn't matter here. It only matters when the element is all by itself. It's a good question. Ionic compounds. Writing formulas. The first thing you have to do is you have to write the formula for each ion, including the charges. And students tend to skip this part. And they'll just start writing down the formula for the compound. Really, you need to write it down with the charge. The 2 individual ions, write down their charges. Then you look at the charges and you figure out how many of each that you need. If the charges are the same, +2 and -2, you need 1 of each. Just push them together, get rid of the signs, and you're good. If it's not the same, then you may need to do that crisscross thing. If you have multiple polyatomic ions, you need to use the parentheses and do not show charges in the formula. So when I write a formula for an ionic compound, I may not write the formula of each ion with the charge, but I see it on the whiteboard in my mind, right? I see it, I look at those charges mentally and put them together. I've been doing this for longer than I really would like to admit. And the thing is it going to be okay? It's having an issue. But when you're starting out, you got to write these things down because the charges tell you how to put them together.